Hi, dear students. Hope you are staying safe and you are in good health condition. Today, we are continue our IGCSE course for chemistry subject, and I would prefer we focus on lesson 10 because when I check the questions in past paper, I have found that this lesson is very important, and at least there are some question will come from this lesson 10. And today we are going to cover pages between 252 to 259, and the topic is organic chemistry. Uh, this part is focusing on carbon, the carbon atom. The carbon atom has can make a different type of material, different type of compound, and it's very talented and very able to form many different with different shape and different compound which is involved in our life. Because of this ability of the carbon, um, lots of information and knowledge comes from this part, and it creates a new branch in chemistry that called organic chemistry. Okay, because this is contain a broad knowledge of chemistry, and the chemists separate this part as organic chemistry. And we have this major in university or like uh, institutes that chemists only focus on organic chemistry. Like my major, I graduated organic chemistry in my master degree. Okay, so uh, organic chemistry is a study of the structure, properties, composition, reactions, properties of the carbon contained compounds. The compounds which is contained with carbon might be included oxygen, hydrogen, or other atoms, but mainly they have included carbon atoms. As I mentioned, that carbon can create several or many structure such as diamond or graphite, fluorine, and nanotubes. There are some like important example for the structures. Diamond, as known, is a very strong material. Is very strong material, and if you look at the bonding, you can see the carbon make a bond with other carbon in different way compared to the graphite. On the right, you can see the graphite or nanotube and others. So here we have uh, angle of 109, around 109 between the carbon, and on the right graphite you can see that carbon make a circle, make a ring, and which is a hexagonal ring, and the angle is around 120 angle between the carbons. Okay, so each sheets of uh, graphite or carbon layer can be placed over the another sheet of uh, carbons. Okay, Fluorine is called also bulky ball, if I'm not mistaken. Bulky ball is famous as a fluorine also. It look like a ball, and it's constructed by the attachment between five membered ring, uh, pentagon and hexagon rings, and make it this shape. And also nanotube is another form of carbon structures. These uh, structures are constructed only by carbon, not other atoms. But there are many unique properties of the carbon. Carbon has three special features under covalent bonding. As we studied before on chapter 3, I think, carbon can make a covalent bonding because of their group and the placement of the carbon in the periodic table. It's carbon is a non-metal and it can create covalent bonding between with the other atoms. First is carbon atom can join to each other to form a long chain. Other elements can then attach to the chain. Here, as you can see, it's very simple carbon structure. There is a bond between the carbon and the other, like hydrogen, attached to the carbon. And another unique feature is carbon atoms in a chain can be linked by single, double, or triple covalent bond that I will explain more about this. Carbon can share two atoms between two carbon atom, and they can create one covalent bond. And each carbon can share two electrons, that means totally four, and they can create double bond between two carbon, and also they can share totally six electron, and share six electron and create a triple bond. Triple bond is shorter than these are like extra information that I'm giving you. It's shorter than double bond, and double bond is shorter than one um, single bond. So if we have the single bond, each carbon can attach to the another three atoms. But when we have a double bond, each carbon can attach to two atoms, like two hydrogen each carbon. And if we have triple between carbon, each carbon can attach to only uh, one atom, because each carbon maximum can attach to four atoms. So number three, carbon atoms can also arrange themselves in a ring. When they create a chain, they can they can each end, and the first carbon and the last carbon can attach together and make a ring. The ring, here you can see the example here. um, Also carbon can attach to oxygen and hydrogen, and they can make a different size of ring, like heptagon or hexagonal or pentagon or tetragon and trigon. And here I just took it from your book. This is a very simple carbon compound, that is methane and then ethane and the other forms. And this is the ring form of carbon that oxygen and hydrogen can attach to carbon or yeah, carbon. And here just a presence of a double bond between the carbon. Attachment between carbons and create a long chain is very important in our life, and like DNA, which is involved with our metabolism or our body, uh, is a long carbon chain. A long carbon chain also can be example for cellulose or glucose, a different type of sugar which our body needs, and uh, so it's very important in natural life. But uh, we need to look at hydrocarbons. What is hydrocarbons? If we see the name is hydrocarbon, that means hydro comes from the hydrogen and carbon comes from, of course, carbon. Hydrocarbon is the simplest type of organic compound. I said that organic compound mainly constructed by carbon, but you can find oxygen, nitrogen even, and many other elements in this organic compound. But hydrocarbon is the simplest one. That means only carbon and hydrogen. Okay, so the simplest organic compounds is hydrocarbon, and hydrocarbon, as we can find out from the name, is only they only contain carbon and hydrogen. um, Hydrocarbon can be divided to three main groups. The first one is saturated hydrocarbon, um, which is included of alkanes, and the other two groups are unsaturated hydrocarbon. One unsaturated can be alkanes, and another one can be alkanes. Okay, so we have alkane, alkenes, alkanes. Okay, for the last one, alkanes, I couldn't find like enough information in your book, so I will not extend or develop this part. So far, we are focusing for alkane and alkenes. What does mean formula that I'm showing here? Meaning the hydrocarbons only contain carbon and hydrogen, right? So on the formula we have C and H, that means carbon and hydrogen. N is a number of carbon. Okay, in all three formula, N means number of carbon. If you have one, if you put one here, one carbons, so how many hydrogen we will get? We will get 2 multiply 1, meaning 2, and plus 2, that means 4. So we will get 4 hydrogen. Each one carbon we will get 4 hydrogen. So if we put 2, how many hydrogen we will get in in alkane group? Okay, if we have 2 here, 2 multiply 2 plus 2 means we will get 6. Like here I put this example ethane. We have 2 carbon, and each carbon can attach to the 4 atoms, neighbor atoms, and so totally we will get 6 hydrogen. This formula can be used for saturated hydrocarbon are the group name is alkanes. For unsaturated hydrocarbons is different, is CnH2n. That means if we have two carbon, okay, same, put 2 here, 2 multiply 2, it's 4, so we will get 4 carbon, like here. This is an example for n equal 2. So here is ethane. I will explain more about the alkenes, okay, in the next slides. This one we just put away and no need to focus on this part. And these two saturated hydrocarbon alkanes and unsaturated hydrocarbons alkenes. Okay, so here you can see uh, this one have been here has been here from your book, methane and ethane, propane, butane, pentane, and hexane. So this is the molecular formula. If we have one carbon, we have 4 hydrogen. If we have 2 carbon, and there is 6 hydrogen. If we have 3, and we will get 8 hydrogen. And there is a prefix of N that showing from the alkane group, and med or eth, prop, but these are Greek number. Okay, that means 1, 2, 3. It's from Greek language, Greek number. So, and here also you can see the number of carbon atoms. That means N, that I explained in a previous formula. And one important thing, when we increase the number of carbons, the chain will be longer. Okay, like here, this one I put I took from the internet, and I put it here for more clear explanation. Until we will have here until 10, and even though there are more and more longer chain for hydrocarbon alkane. And one important thing is, when we increase the chain, increase the number of uh, carbon, the boiling point will be increased. That means uh, the uh, the chain will be stronger. Okay, the forces between atoms, between carbon, all hydrogen, the forces will be stronger, and they can absorb to each other, they can hold each other stronger, so the compound will be stronger. So that means a longer chain need more energy to be boiled. If you have the, like, a dish of longer chain of alkane, you need to give more heat. You need to give more heat until it get boiling. So here, for example, the methane, only one carbon in minus 164 Celsius can be boiled. Very, very cold environments. But in hexane, 6 carbon, you need to give 69. That is very hot. It's a very hot environment. You need to give this amount of heat until it gets boiled. So the physical condition, the first four alkane, they are form of gas. Okay, because in our temperature, in the natural temperature is around 25. I mean, the room temperature is around 25 to 30 Celsius. So these four can be in form of gas. That means they have been already boiled. They have already been form of gas. And another one, the rest from the penton until maybe around 16 or 18. I'm not sure. They are in form of liquid, and after that they get form of between very solid liquid, and then solid actually. So these are because the form of liquid or gas is related to their boiling point, and the boiling point is related to the stability, their I mean the strength. So next slide, just for a presentation of the formula, the name, and this is the structural formula, and this is molecular formula, and these are just presentation of 3D structure. Okay, 3D structure of methane, that carbon can be attached to the 4 hydrogen with angle of 109, and these are ethane, can be included 2 carbon with that each carbon can attach to the 3, and propan and butane. Okay, and there are as I said, there are 3 important formula: a structural formula, and empirical formula, and molecular formula can be used for organic compounds. So we are studying organic chemistry, we are dealing with carbon and hydrogen, and are known as organic compounds. So we use 3 different formula to show the organic compounds. The first is empirical formula, and second molecular formula, and a structural formula. A structural formula is clear. I think it's obvious. You can see that we need to draw the bond and atoms which they are attached by bond, the drawing. But what is the difference between empirical and molecular? Between CO2, there is no difference between empirical and molecular formula, and also water, there is no. But for other carbon like nitrogen dioxide, actually molecular formula show you all the number of the nitrogen and oxygen. That means each 2 nitrogen can attach to 2, and together they get 4 oxygen. But the simplest way of showing this formula, molecular formula, is empirical formula. If you divide 2 to 2 and 4 to 2, you will get 1 and 2. That means each nitrogen can get 2 oxygen. And also for another one, you can phosphate oxide, you can divide to 2 and 2, you will get 2 and 5 for phosphorus and oxygen. So the difference between empirical and molecular formula shows you the whole number ratio, all the number, but empirical make it simple. Okay, you need to divide each in all the numbers should be divided in one number. Like one number can be 2, can be 3. Like here the last one is one type of I think sugar. uh, it divide to 3. All the 3 atoms must be divided to 3. Oxygen divided to 3, so you will get 1. Hydrogen 18 divided to 3, you will get 6, and carbon divide to 3, you will get 2. So the simplest formula can be known as a empirical formula. So burning alkanes is very uh, vital in our life, and we need to burn alkanes for our daily life. But we should know what is the products after after alkyne burn. Methane and actually we need oxygen. That means burning need to be in a place that there is enough air. So air can provide oxygen. 21% of our atmosphere, as we know, there is oxygen, and the environment or the place should be enough oxygen, and the result from the reaction between methane and oxygen is carbon dioxide and water. And also methane and oxygen same. So we can conclude that the result from burning alkane is carbon dioxide and water. The water is form of gas. Look at here. That means it's a vapor. It's not liquid water. This can be considered as the fuel. What we call it's a the fuel that we use for car or motorcycle. Okay, that is a type of hydrocarbons, and then the rest of the result from the using fossil fuel in our car or motorcycle, we are producing carbon dioxide and water vapor, which it damages our nature. And uh, there is there are two notes which is important, and I put it here. Methane uh, is major part of natural gas. Okay, if you have multiple choice question that ask you what is the major part of natural gas, methane, propane, butane, or hexane, something like that, so you should know that methane is the major part of natural gas. That I think it mentioned in chapter 1 also. For propane and butane, they are very important for our daily life as we use it in you know uh, these two gas produce very hot flame, and they can be sold as liquefied petroleum gas that called LPG, and we store this gas in very high pressure and decreasing the temperature, and I mean it's very cold to make it a liquid. As I mentioned before, these two are form of gas, but when we decrease the temperature and also increase the pressure, we can store these two, butane and propane. These two is form of they are in form of gas, and but if we decrease the temperature and increase the pressure, we can store in cylinders that we use for cooking or other purposes. Okay, let's move on alkenes. Alkenes is unsaturated hydrocarbons. Why we say unsaturated? That means unsaturated. That means they are interested to react. But the previous one, they are very less. They are very less interested to react with other atoms. They can react, but the reaction rate is very low. So look at here. What is the difference between these two? There is one double bond. The main difference between these two compounds, alkanes and alkenes. The most the obvious difference is double bond, and these double bonds make the alkenes very interested in reaction. That's why we call unsaturated. That means they don't feel full, they want to react. And so unsaturated hydrocarbons, uh, one group is alkenes. The formula is CnH2n. I explained for this, and here also is only a presentation of alkenes. The simplest alkenes is ethene. Okay, ethene is the simplest one because um, only one double bond we have, uh, just one possible double bond can be found in this compound. But the simplest compound in alkane is methane. Only one carbon, only one carbon, because there are four simple bond, I mean single bond. But in alkanes, the simplest one is ethene. Okay, so next slide shows you the properties of alkenes, the first four alkenes, ethane, but we don't have methane or methane, something like that, because only there is only one carbon in methane. So we will not put any, uh, we cannot design any double bond for methane or methane. We don't have methane, only there is only one carbon. But the simplest way is ethene, that we can find a double bond. So the property is almost very similar with alkane, between alkene and alkane. So these are, you can see the number of the carbon increase, and the formula, molecular formula, follows CnH2n. So if we have two carbon, we will get four hydrogen. If we have three carbon, we will get six hydrogen. If we have four carbon, we will get eight hydrogen. So this is the formula. And boiling point also, the first three in alkene is gas form, and the fourth one is liquid form. And also same, when we increase the chain, I mean increase the number of carbon, they will be more stronger. Okay, like the alkane, they will be more stronger, more stable, and they need more energy to get boiled. And about the burning al uh, alkanes, I this is my mistake. I wrote alkanes. It's not alkane, it's alkenes. Okay, just you put e. It's same with the alkane. um, like ethene, if ethene react with oxygen, enough oxygen in environment, that means burning. So carbon dioxide and water in form of gas, meaning vapor, can be produced. Double bond in alkenes is known as a functional group also, because this is a part which which has a function. I said that alkenes are more reactive than alkane. This is because of the double bond in alkenes. So because of these properties also, we can say it's a functional group. That means a part or a group which give a function to alkenes. The alkenes can be functionalized. So there is one test that we can compare between saturated and unsaturated hydrocarbons. I said that hydrocarbons unsaturated, that means they want to react more. This is, we can give an example as a person who is hungry are a person who is full, already eat. Okay, so a person who is full, um, he or she doesn't prefer to eat more because he is saturated. But a person who is hungry, that means he want to eat more, that person is unsaturated. Okay, 18s are unsaturated, I mean alkenes. Here is an example of ethene in form of gas, is one a member of the alkene. Um it likes to react with bromine. Uh, First, the double bond here can be break down. Okay, the double bond between ethene can be break down. This is functional group. This is a part that alkenes can react with it. And also bromine can the bond between bromine can be break it down, and each bromine can react with carbon. When you break down this bond, each bromine can place on this carbon, can react with carbon and make another new bond with alkene, with alkenes or ethenes. So this is a difference between alkane added or alkene added. When you have alkane, okay, when you have alkane, if you add, for example, bromine or chlorine or anything, the alkane color will not change. Okay, the the color remain stable. But after you add, like for example, bromine to ethene, like here, the color change. The changing the color means there is reaction. Okay, meanings there is reaction. That means ethene react with bromine, and the color of ethene change to the white. Okay, I'm not sure what is the color of ethene. Maybe it was yellow or any color. But after adding bromine on other things, when the color changed, that means there is a reaction. Okay, but alkane has not changed for any color. These are for today. I'm trying to finish this chapter as soon as possible. Then we'll have six chapter and plus these, I think seven or six chapter totally. Then we will go for revision. Before IGCSE exam, we need to have a review and make a correction. I try to give you more tests, and I give you more review, and we will have more revision before sitting for exam. Please give this answer to me, and I will check for your answer. I set two questions, and please also focus on your book for further details. Thank you so much. Take care.